Today we are beginning a new unit about polynomials, and we're going to look at classifying polynomials based on the number of terms that they have and also based on the degree that they have. One thing I wanted y'all to note, sometimes you'll see in directions in a test or in a book to put the polynomial in standard form. And standard form just means start with the biggest exponent and then go down to the smallest exponent. So x squared would come before x, which would come before the constant, or x to the third would come before x squared. But that's what it means to be in standard form, from the largest exponent down to the smallest. So since this is a new unit, I thought it would be good for us to get a definition of a polynomial. So this definition is written at the top of your notes page. You just need to fill in the word polynomial there. And a polynomial is a mathematical expression. It has constants, which you remember constants are things that don't have a variable, like 3 or -7. And it also has variables. Usually we use x, but sometimes it has exponents on it, x to the third, x to the second, x to the fourth. And it can be combined using addition, subtraction, multiplication, and division, but you cannot divide by a variable. So if you do division, you can have a number or a constant in the denominator, but you cannot have a variable in the denominator. We would never have the variable in the denominator of a polynomial. The exponents can only be whole numbers, no fractions, no decimals, no negative numbers, and it has to have a finite number of terms. It has to have a stopping point. So some examples of polynomials: 3x squared plus 5x minus 7. This one has 1, 2, 3 terms. The first 2 terms are joined by addition, and then we have subtraction on the last one, but on either side of that is where the term is. So that's one term. This is one term separated away by the plus, and then this is the last term separated away by the minus. Another example of a polynomial is this one. You can see it has division, but I've divided by a number, so therefore it's fine. I just can't have a variable down here. So this is a second example of a polynomial. Things that would not be considered polynomials, look at this one. Do you see it's got an x in the denominator? So because I have a variable in the denominator, it cannot be a polynomial. Also, I have this one. This one has a negative exponent. Well, a negative number is not a whole number, so therefore this one is not a polynomial either. Okay, first we're going to look at classifying based on the number of terms. So fill in that first blank there. We're going to be looking at monomials. A monomial is a polynomial with exactly one term. So some examples of monomials: 4, that's just 1. There's nothing added or subtracted to it. It's just itself. -6x. And this one, 2/3 x to the third. You can see I've got a fraction there, but that doesn't change anything. It still just has one term. So I would call each of these a monomial. And you may have learned in the past that the prefix mono means one. So monomial, one term. All right, binomial, I bet you guys can figure out it's got the prefix bi. So that means it's going to be a polynomial with exactly 2 terms. Bicycle, bivalve, all kinds of words that start with bi that means 2. So some examples of binomials. Here's one. You can see it has 1, 2 terms separated by a subtraction sign. Here's a binomial. It has 1, 2 terms separated by a subtraction sign. And then here's another binomial. This one looks a lot more complicated because it's got fractions and it's got higher exponents, but it's still one term added together. So that makes it a binomial, 2 terms that are added together. All right, trinomial. Again, I bet you guys can figure this out. Trinomial, like tricycle, triceratops, triangle. A polynomial with exactly 3 terms. My prefix tri there, meaning 3. Some examples of polynomials: 4x to the third, -6x plus 7. It's got 1, 2, 3 terms joined by minus and plus. And here's another one. It's got 1, 2, 3 terms. The third one happens to be a fraction, but that doesn't matter. And these are both joined by a plus. All right, a polynomial, poly meaning many, like polytheist or polymer, 4 or more terms. Now, one thing I want you to notice, all of these words are polynomials. A monomial is a polynomial. It's just that a monomial is a special polynomial. It only has one term. Same thing with a binomial. A binomial is a polynomial. It's just a special polynomial because it has exactly 2 terms. So I don't want you to think that it's not a polynomial until it has 4 terms. We just don't call it that because we have special names for the first three types. But once you get up to 4 or more terms, we just call it a polynomial. This particular polynomial, 1, 2, 3, 4, 5 terms. So this is a polynomial with 5 terms. All right, if you didn't have time to write all that in your notes, pause the video here for just a second and write all those definitions down. Okay, the next thing we need to look at is the degree. So we need to look at this in two separate ways. First, the degree of a monomial. And you remember from the last slide, a monomial means it has one term. So I have 1, 2, 3 separate monomials here. And to find the degree of a monomial, you just look at the exponent. And it's important that this is the exponent on the variable. So I'm going to add that on here. You have to look at the exponent on the variable. So look at this first one, 4x to the 6th. There's my exponent. So the degree of this monomial is 6. When I just have x here, it's got an understood 1 as the exponent. So the degree on this one is 1. With 11, so 11 you don't see an x. There's an understood like x to the 0 right there. So this one, the degree is 0 because there's not an x. It's just a constant. Any constant is always going to have a degree of 0. So even if I put an exponent on there, like if I make it 11 to the 2nd, the degree is still 0 because there's no variable. The exponent you want to look at is the exponent on the variable, not the exponent on the number, only on the variable. All right, so now let's look at the degree of a polynomial. Polynomial, just in this case, something bigger than one term. It doesn't matter how many. These happen to be trinomials. I have 1, 2, 3 terms, 1, 2, 3 terms. And to find their degree, I'm going to look at each one of the monomials separately, and then I'm going to pick the biggest degree of all the ones that I see. Okay, so here I have an exponent of 2. Here I have that understood exponent of 1, and you remember a constant had 0. The highest of all of those is 2. So the degree of this polynomial is 2. It is a degree 2 polynomial. This second one over here, I can see that I have 4 and 2. And again, I've got that 0 right there. The highest of those is 4. So the degree of that polynomial is a 4. When it's a polynomial, you have to look at each one individually. Don't add them up together. Look at them each individually and then pick the biggest of the ones that you see. Okay, so now let's look at, now that we know how to find degree, let's look at how to classify these based on degree. And again, you'll see some lines on your note paper, just fill in the blanks. A constant function has a degree equal to 0. All right, well, that tells me the things that have degree equal to 0, those constants are just numbers, right? So here's a constant function, here's a constant function. Both of those happen to be monomials as well. All right, linear. Linear, you guys have been working with for a long time. You can see the word line inside of there. These are going to make diagonal lines, and they have a degree equal to 1. So this monomial has a degree understood 1 right here. This binomial also has a degree understood 1 because the 5, remember the degree on that 5 is a 0. So the degree of both of these is 1, therefore they are linear. Quadratic, that's what we've been working on the last couple of units. That has degree 2. All right, so here I have 2 examples of quadratic polynomials for you. This one is a monomial, degree 2. This one, 1, 2, 3 terms, is a trinomial, and the highest exponent that I see there is a 2, so this one is quadratic. Cubic. Cubic has degree 3. If you think about how a cube in geometry, a cube has 3 dimensions, that'll help you remember that it's a degree 3. All right, and here's a couple of examples. Here's a monomial that's degree 3. This one has 1, 2 terms, so it's a binomial with degree 3. I just picked the biggest. I know this one has an understood 1. That's a 3. 3 is the biggest, so this binomial has degree 3. And the last word you need to remember is quartic. Quartic is degree 4. All right, and if you look at that prefix there, quart, you can think about quarts of milk. There's 4 quarts of milk in a gallon, or quarter. It takes 4 quarters to make $1. So when you see quart, the degree is going to be 4. And here's an example of a quartic polynomial. I have an exponent of 4, 3, 2. This one is a constant, so it's a 0. The biggest on that is 4. So the degree of this entire polynomial is 4. Okay, so just like before, if you didn't have time to get all those written on your note sheet, pause the video right here, write all of those down, and then continue on with the video. Okay, so let's look at these 3 examples. They're on your note sheet, and we're going to classify each of these based on both their degree and their number of terms. So let's look at this first one. Let's look at the degree. Okay, so I see that this first x has an understood exponent of 1. 7 is a constant, so its degree is 0. So the highest between 1 and 0 is 1. This is a degree 1 polynomial. We call that linear. So this is a linear, and I see that it has 1, 2 terms. So based on its number of terms, I would say this is a binomial. So I have a linear binomial. All right, let's go to this one. So first of all, based on its degree, well, this is a monomial. It only has 1 there, so that's degree 3. And I remember 3 dimensions like a cube, so this one is cubic. And I already said this one just has 1 term, so this one is a monomial based on its number of terms. All right, let's look at this last one. So this one is not a monomial. I have to look at each one separately. The degree on this one, I can see that 4, that's a 4. The degree on that one is a 1, x to the first. That's a constant, so the degree there is 0. 4, 1, 0, the biggest of those is 4. 4 quarts in a gallon, 4 quarters in a dollar, so this is a quartic polynomial. And now if I look at how many terms, it's got 1, 2, 3 terms. So therefore, I would say that this one is a trinomial. I have a quartic trinomial. Okay, so if you guys will work on the questions on your worksheet, make sure you get those right before you do what you need to turn in today.